Chef and an architect decide to grab ice cream at the local ice cream bar. The ice cream bar sells 3 different flavors of ice cream: chocolate, vanilla, strawberry. The chef is very particular about how his food is organized. He knows he wants 3 scoops of ice cream, but he's worried about how he's going to arrange the scoops. The chef thinks about how many different 3-scoop ordered arrangements he can make from 3 different flavors of ice cream. Does he want vanilla on top, strawberry in the middle, and chocolate on the bottom? Or does he want strawberry on top, chocolate in the middle, and vanilla on the bottom? After an exhaustive 15 minutes, he was able to create an extensive list of 27 different 3-scoop arrangements. What he realized after creating this list was there are 3 different flavor options you can use as the first scoop. You can either have vanilla, chocolate, or strawberry. For the second scoop, there are also 3 different options you can use. You can use either vanilla, chocolate, or strawberry. And finally, for the last scoop, you can use, you guessed it, 3 different flavors of ice cream. You can either have vanilla, chocolate, or strawberry as the last scoop. Let's represent a number of different flavors as n. Since there is n equal 3 flavors for the first scoop, and n equal 3 flavors for the second scoop, and n equal 3 flavors for the third scoop, the number of 3-scoop cone arrangements the chef can create from 3 different flavors of ice cream are n times n times n. Or in other words, n k times, k representing the number of scoops for each cone. When he used this formula n to the power of k to check his answer, he was in fact correct. There are 3 to the 3, or 27 different ordered arrangements of 3-scoop cones he can create from 3 different flavors of ice cream. Now that the chef was finished deciding, it was the architect's turn to choose her 3 scoops of ice cream. The architect does not have the same palate or experience with food as her chef friend, so it did not matter to her the arrangement of flavors. All the architect wanted was 3 scoops of ice cream. The architect quickly thinks to herself what are the different ways to select 3 scoops of ice cream on a cone from 3 different flavors of ice cream. She can have vanilla, 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 or vanilla, vanilla, chocolate, or vanilla, vanilla, strawberry, and so on. It is important to note that when you say unordered arrangement, vanilla, vanilla, strawberry is the same as vanilla, strawberry, vanilla, and strawberry, vanilla, vanilla. The order of the scoops doesn't matter as long as she gets all 3 scoops on the cone. She looked at the 3 flavors of ice cream in the display and started using the stars and bars method. She visualized 2 dividers to create 3 different categories. First, she placed the 2 dividers like this and saw the 3 categories correspond to vanilla, chocolate, and strawberry. Then she decided to move the 2 dividers all the way to the right, then fill in the scoop flavors based on the categories they lived in. She also moved the 2 dividers to the left and filled in the scoop flavors. She continued this process until she had exhausted all her options. In the end, she realized she can create 10 different arrangements of 3 scoop cones from 3 flavors of ice cream and placing the 2 dividers in many different arrangements. The stars and bars method correlate to the following theorem: the theorem for solving an unordered selection of size k from n types of objects. Let's create 5 slots. The 5 slots include the 3 different flavors of ice cream plus the 2 dividers. Now you need to figure out where the first divider will go. Note, you have 5 options as to where the first divider can go. Either here, 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 and here. Now that you've placed the first divider down, there are 4 remaining slots as to where the second divider can go. Now that we've taken care of the dividers, you can multiply 5 by 4. The 5 is for the 5 different options for the first divider and 4 for the number of options you have for the second divider. Now we have to divide by a factor that will take care of the number of ways of permutating around the 2 dividers. The number of ways to do that is 2 by 1. There are 2 dividers, so you get 2 choices to say which one will go first, and then 1 choice to say which one goes next. Dividing by this product also removes the problem of ordering. Now if we rewrite this in combinatorial notation, we get 5 choose 2. The more formal formula is n plus k minus 1. The length of flavors and dividers choose n minus 1 ways to select k objects, k being the flavors of ice cream. After calculating, she realized she was correct. There are 10 different arrangements of 3 scoop cones from 3 different flavors of ice cream. In the end, from the list of different arrangements, the chef decided to get a scoop of vanilla on top, strawberry in the middle, and chocolate on the bottom. He ordered his scoops based on his least favorite flavor to his most favorite, and the architect got 2 scoops of strawberry and 1 scoop of chocolate. If you have any questions, please leave them in the comments below. Thank you for watching. Bye!